Welcome everyone to our Dairy Foods virtual office hours for Thursday, December 1st. Hope everybody's recharged from this Thanksgiving and ready for that last dash to the end of the year. I was at the Grow New York Food and Ag Startup Competition just before the holiday, just featuring businesses with innovative new food products, novel processing, and analytical technologies. And as a dairy company looking to bring in a new technology platform, one of the key questions you got to ask yourself is, how do we effectively evaluate this and decide whether or not it's the right investment for our company? And so fortunately, we're at a research institution here that is driving technology development and assessment. So we've got a deep panel of experts to ask questions about different technologies that are coming into the market or have been established in the market. And what we're going to do today is start off with an overview of this decision-making process with Aljosa Trmcic, who is a dairy extension associate here in the Department of Food Science. And then we'll kick it over and open it up to questions for the panel. We got a great panel today, like I was mentioning. We've got Kim Bukowski, who is a dairy foods extension associate here in our department. We've got Nicole Martin, who's the associate director of the Milk Quality Improvement Program. We've got Carmen Moraro, who's a professor and chair of the Department of Food Science here at Cornell University. Olga Padilla-Zakor, who is a professor of food science and the interim director of Cornell Agritech. We've got Rob Rallier, who's a senior extension associate and the dairy pilot plant manager. We've got Abby Snyder, who's an assistant professor of food science, and myself, Sam Alkane, an assistant professor of dairy fermentations here in the department. When we're talking about new technologies, we also want to make sure, right, that they're approved, regulatory approved. So we've also got some representatives from the New York State Department of Ag and Markets, the Division of Milk Control and Dairy Services, to kind of help us with any regulatory questions or questions around novel technologies that they'll be able to answer as we go on. So with that, I'm gonna pitch it over to Al and let him take us away on this journey.
Yes, thank you, Sam. Am I good? Visible?
Good.
Okay. So I put this short presentation together to get us started on this topic of new technologies. And the title itself already, I think, communicates the main point. So the decision to bring in new technology or not should be an objective one where you consider multiple points of the new technology. And I will try and capture some of these points in this presentation. So a quick agenda, I will do a short intro with some of the results from our recent survey with our fluid milk processors in New York State. I'll go through some of the points I see important when considering new technologies. Within these points, there's one very important point, which is evaluating the scientific evidence that the technology can do what we expect it to do. And I will give you an example here of one technology that we recently evaluated. And then after the final conclusion, we can open it up for questions, answers, and any comments that you have. So if you look at the activities at our food science department, a lot of it revolves around developing new technologies, evaluating new technologies. And I'm actually really happy that the main driving force, I guess, at the department when it comes to new technologies is here with us today. So when it comes to new technologies in dairy processing, in the recent years, we got maybe a bit higher degree of requests for opinions to evaluate technologies. So we did a short survey with fluid milk processors in New York State to better define this interest. And it looks like majority of them, like almost 90% of them, are actively looking into new technologies and how they can benefit from them. They say that for them, the major source of information about new technologies are usually the companies that they are already working with, and that makes a lot of sense. But there are also other companies, outside companies, that are reaching out to them, introducing and offering new technologies. Other sources would be professional publications, scientific publications, trade shows, and similar. Obviously, academia is involved in a lot of these sources. But under other sources, they also listed direct contact from academia, which I'm really happy to see because that means we are doing our job. These are some of the technologies that the fluid milk processors say are most often evaluating. So new processing technologies and, of course, cleaning and sanitizing chemicals are on top. And then cleaning and sanitizing equipment, filling equipment, packaging are not far behind. The digital solutions and alternatives are maybe less frequently considered, but they're still interesting to some of them. Okay, so what are some of the points that the industry should consider when evaluating new technologies? First of all, think about what are your needs and expectations of the new technology. So are you looking into making the same product just in a different way? Are you looking to make a completely new product? Are you looking into extending the shelf life, increasing capacity, increasing yield, lowering the costs, lowering the waste you're generating? For example, is there a workforce shortage and you're looking into new technology to replace some of that workforce? So all these would have to be listed with all your needs and expectations. So then in the next step, you can evaluate individual technologies against your expectations and see if the technology can really fulfill those needs and expectations. As part of your evaluation or separately, of course, you would look into how much does this cost. So how much does it cost to bring in the technology? How much does it cost to keep the technology and keep it running? And then finally, what is the regulatory status of the technology? Like Sam said, can the technology replace some other equipment, or can it be just an add-on to the technology that you already have, or maybe don't have? So that's also something that's important. So when I'm bringing this new piece of equipment in, what else do I have to bring in to achieve these goals? You know, sometimes they will say, bring in this piece of equipment in and it's going to extend your shelf life, but maybe they don't tell you that you also need a new filler to get there. Okay, so what is out there? What are the technologies that are out there? So on the right, I made this word cloud from a list of new technologies that we have been looking into in the last 2 years. And on the left, there's a list of topics that a journal, Agri-Engineering, is interested in their special section in the making that will be on novel aspects of dairy processing technologies. Obviously, a big one is thermal processing, and then also non-thermal processing that maybe eventually could replace some of those thermal processes. So under thermal processing, we are thinking about, are there alternatives to conventional VAT pasteurization, HTST pasteurization, ultra pasteurization? Maybe one example would be microwave heating. So taking that whole microwave technology and applying it to industrial processing, or omics heating, so where you're using the electric current to heat the matrix. When it comes to non-thermal processing, there are a number of non-thermal alternatives. One that we hear a lot about is the high pressure processing, or HPP. I guess when it comes to dairy, probably less likely that it will replace pasteurization. If nothing else, it's a batch system that would probably not be able to take care of the volumes that we are looking into the same way the HTST, for example, could do. But when it comes to HPP, there are applications in dairy that could be interesting for the dairy industry, and I'm happy to see Dr. Carmen Muraro here, and maybe if there's interest, she could share some of those applications. We have a big UV in our cloud. So UV is being used in more and more applications, including in something that goes by called UV pasteurization. So a technology that is well established in juice and beverage industry, but maybe less common in dairy industry. A big reason is that UV light has a difficulty penetrating non-translucent liquids. However, there are companies that say they have solutions for milk or non-translucent liquids. So this is maybe something that we will see more of in the future. Some other alternatives would be microfiltration, ultrasound, pulsed field, electric field. When it comes to drying, obviously, evaporation followed by spray drying and fluidized bed drying are still the gold standard. And you can imagine even within this kind of traditional components, there are innovations that are improving the efficiency, the capacity, the quality of the final product, and so on. There's also a lot of innovation in drying when it comes to what is the component that's being dried. So different milk fractions, protein fractions, with lactose, without lactose, whey, upcycling streams, secondary streams, and so on. Next one on the list is fermentation. So obviously a lot of innovation there. If you think about it, maybe we identified 1% of microbes that are out there in the world. So as long as we keep discovering those microbes, getting to know them, there will always be innovation in starter cultures. And obviously starter culture companies are doing this at a lightning speed. We also have, Dr. Samuel Kane here hosting our office hours every time, but he's also an award-winning fermentation innovator and acid whey upcycling guru, I can say. So maybe later on, he can also share some of his work. When it comes to fermentation, we also have innovation in bioactive components, probiotics, encapsulation technologies to protect the active ingredients and achieve maybe more targeted delivery. There's a lot of novel dairy ingredients that are coming out of the separation, the fractionation, the concentration, and also specific milk component modifications. And then there are also other innovations like 3D printing and similar. So these were just maybe some examples of the technologies. There are obviously other technologies that I didn't mention. For example, a lot of innovations in chemicals and technologies for cleaning and sanitizing, a lot of innovations in packaging material, packaging technologies. And there are obviously a lot of technologies that maybe I'm not even aware of. I feel like whenever I look into this, I always find something new and interesting. So any of these technologies, or many of them, can be attractive for us to fulfill our needs. So before we go into B, so can the technology really fulfill those needs? I would like to say that really this financial part is important. One, we said, what is the cost of the technology? And with this cost, we should not forget other potential initial fixed costs, like you have to rearrange the processing room, or you have to build a new processing room. Maybe you need to introduce new piping, upgrade the electric power, adjust your CIP system, train the operators, and similar. Obviously, after the fixed part, we have to consider the variable costs. So what is the cost of extra electricity, extra water, cleaning chemicals, manpower, consumables? What is the waste that we are generating? Are we losing any raw material, product, and so on? All this has to be counted in the cost. And then the last one, what is the regulatory status of the new technology? Like we said, can it replace? Can it be add-on? For example, if you think about grade A dairy products, these are by definition pasteurized products. So how much are we gaining by bringing in new technology that can offer that kill step when we still have to keep that pasteurization as the main kill step? We have some of our colleagues from dairy branch of egg markets here, so maybe they can share with us any experience or just in general any recommendations when it comes to bringing in new technology, maybe even new or old, it doesn't matter. Another part maybe worth thinking about is, so you're bringing in new technology to fix maybe one issue, maybe to eliminate a biological hazard, but worth thinking is, are you bringing in any new hazards? So, and it can be even like outside of general food safety, it can be occupational safety. So do you need new PPE? What is the waste that you're generating with new technology and similar? So all these things have to be considered. Okay, so a case study on evaluating new technology. And before I go into this, I have a disclaimer. So this is really not about attacking a specific technology, attacking a specific company. For example, in this case, the company says the technology works. I'm not saying it does not work. I'm just doing a critical evaluation based on the information that's available to me. So this is not just to go through the evaluation with you and how you should do the evaluation, but it's maybe also something to think about the companies that are offering these technologies. What kind of information should they make publicly available to show that technology works? and not just ask us to take their word on it. So the technology we were asked to evaluate at one point is called millisecond technology, or MST. This technology is advertised as a low temperature, short time process where temperature does not go above 158 Fahrenheit. So it consists of this vacuum chamber where milk is first dispersed into micro-sized droplets, then passed through a quick heating and cooling process under vacuum before these droplets are again collected into a continuous stream and exit the chamber. So the rapid heating and cooling under this drop in atmospheric pressure is set to inactivate the vegetative cells and make the bacterial spores unable to germinate. Now, although they say that the technology could work on its own, it is not to be incorporated, it has to be incorporated into regular continuous pasteurization flow. We mentioned regulatory status can be added on. This one, it cannot replace pasteurization. It can only be added to the pasteurization flow. And there are obviously several reasons for that. So this is one setup that was used. So going from balance tank through a regen section, going through heating, holding tank, and then it enters this MST chamber where, like we said, the milk is dispersed, heated, cooled under vacuum. And then they say that each droplet is supposed to pass through the chamber in a little bit more than 6 seconds, and then exits out as a continuous flow, going through, again, regen section, cooling section, and then past the flow diversion device into P-tank or filler or anything else. So post-pasteurization contamination, or PPC, can technically already occur before the flow diversion device, but generally we say it occurs in the lines, going to the filler, going to P-tank, in the P-tank, during filling, even packaging can bring contamination in if it's not made, stored, or handled appropriately. So the key point here is that it doesn't look like this technology is addressing PPC, the post-pasteurization contamination. And yeah, so what are they advertising? So they say that they promise that they will give you HTST milk with shelf life of UHT milk. And it is the statements like this that are maybe confusing at best, since we know that shelf life of UHT milk is about 6 months at room temperature. So are they offering something like that? At a closer look, what they're actually offering is more of an extended shelf life that's beyond 40 days or beyond 30 days, depending on how good your filler is. And then at even closer look, you can see that there is a disclaimer saying, depending on the post-pasteurization environment, which is probably referring to the fact that probably this technology is not addressing PPC. So based on our experience working on reducing the spoilage of pasteurized milk, about 40 to 60% of milk produced spoils due to outgrowth of gram-negative bacteria, which are most likely introduced through post-pasteurization contamination. This means that maybe half of the fluid milk made with the use of this technology will never reach those 30 or 40 days that they promise, but will still spoil much faster. In our experience, that would happen maybe in 7 to 14 days. So you get the promised shelf life of only half of the product you're making, and even this you can only get if this technology is capable of inactivating spores of spore-forming gram-positive bacteria that are generally able to survive pasteurization, germinate, grow, and spoil milk. Again, in our experience, that would be about 14 to 21 days of shelf life. So if this technology is not able to inactivate spores that spoil milk, it means that even more product, maybe 30 to 40%, will not be saved from this premature spoilage. So again, number one, we don't know if this technology, is probably not addressing the PPC, which is spoiling a large percentage of fluid milk. And number two, in order for this technology to be to have an impact, it would have to be able to inactivate the spores of spoilage spore formers. Now, to determine does this technology have an effect on spore formers or not, we have to look into scientific literature, studies, to see if this technology functions as promised, and find the scientific evidence and validation of this effectiveness. So when I did a search through a popular scientific literature browser, PubMed, I didn't get a lot to work with. So of 2 scientific papers that were evaluating this technology, one evaluated removal of viruses from blood plasma, and only one evaluated inactivation of microbes in milk. When I used Google, I found 13 web pages and documents, of which 2 were referring to a patent of this technology, 1 web page of a patent owner, and 1 page of the manufacturer. Both of them are only referring to this one single paper that I found, which maybe indicates that this is actually all there is when it comes to scientific evidence. This was a bit surprising to me. Just as a comparison, I put on the bottom the number of scientific papers on something like HPP. There's almost 400 papers with high pressure processing in the title, or more than 800 with high pressure processing in the abstract. So when I looked into that paper, specifically, it had 21 references, which one is referring to the patent, and none of the other ones are referring to any prior studies. So it looks like not much was done on this technology before this first study, at least not the publications that will be available to me or us. I'm sure that maybe there can be information available in other languages, or maybe in some resources that are not captured by these electronic databases that I used. So the paper was published in 2016, and it was cited 4 times, of which none of them represented any additional study or continuous study of this first one. One of the citing papers is actually a review article on extended shelf life technology. And I will just show you one section of this review because it really captures my conclusions of this technology. So the MST technology has the potential for processing milk, although as Meyer and the colleagues commented, so the authors of the original study, several parameters of the process need to be examined, including the efficacy of the process to inactivate more thermally robust microorganisms such as bacillus species. So if you look at the original study, they found both bacillus and Paenibacillus species in the processed milk, which are the 2 cold tolerance spore-forming genera most commonly found in pasteurized milk as spoilage organism. And they finish with, until the technology can be shown to inactivate spore of cyclotolerant, so cold tolerant spore-forming bacteria, it has limited application for production of ESL milk with long shelf life. So this is the science we have available on this technology. But the technology still looks very much serious. So the company, the web page, everything looks very much attractive. So there are commercial launches, ribbon cutting events. They say the technology is already installed and working in one of the Midwest dairies. Ohio Department of Health has cleared it. There's another unit installed in a dairy facility in Puerto Rico. There are articles about this processor where they were able to extend the shelf life from 12 to 33 days with this technology. They still say spore formers are inactivated. They still say you get 30 to 40 days of shelf life. All in all, very, very attractive. So again, I hope it does not look like an attack on this technology. It is just an example of how information is not available to support the claims. Maybe the technology works, but I don't see the right information to show this. One thing maybe is that often the claim that technology works is not based on a controlled experiment, but experiments where several different factors are changed simultaneously, and then you don't know what the observed result is. Is it from factor 1, factor 2, or the combination of them? So none of that. So example, that success of the Puerto Rico plant where shelf life was extended from 12 to 33 days. So there's no information how they got there. I don't think installing just one piece of equipment that does not address PPC can get you there. And maybe we can just leave it at there. So what kind of advice can we give in this situation? So number one, don't consider this technology if PPC is the main reason your product is spoiling. If you have PPC problems, focus on GMPs, cleaning, sanitation, sanitary design of your equipment. Look into your preventative maintenance frequency. Maybe what you can do is install the QMI ports and sample different sections of your production line, identify where the contamination is coming from, and then do something about it. Number two, if you're still considering this technology, make sure you ask a lot of questions. Mainly, try to understand why is there discrepancy between available scientific information and the information in the marketing material. So when they say it worked in Puerto Rico, ask for details. How was this done? And then finally, ask to have the process validated in your plant, on your raw milk, in your conditions. So and make sure that it works in your specific situation. Okay, so this is this case study on how to evaluate new technology. What can we say in conclusion? So take your time with the evaluation of the technology. I gave you these 5 questions to consider. There can be other questions, and think about them, whatever is relevant to you. Make sure you have the scientific evidence that technology works. Make sure it's legal and appropriate to use the technology. Make sure you validate the technology, like we said, and you make sure it works in your specific situation. And then finally, make sure you did a proper cost-benefit analysis to make sure that the bottom line is in your favor. And when you're doing this, don't hesitate to ask for opinion, ask for help. For example, when we are asked to evaluate new technologies, we put these short one-page information sheets together to get you started on it. And we have them stored on a web page where we have a tab with the new dairy processing technologies. And you're more than welcome to join and see what we have there. So it's not just millisecond technology. We have info sheets on superheated steam technology, HPP biosensors, and similar. So check this out. We're also available to answer any questions in person. Just to say, a big part of what we do is confidential and discreet. So I don't know, signing NDAs was never a problem for us. And again, a big part of asking for opinion and help should be you talking to your state and local regulators. And I don't have to tell you that these conversations are nothing but discreet and confidential. Okay, so this is all I prepared for this. We can move on to the questions and answers. But before we continue, I have to just acknowledge the New York State Dairy Promotion Advisory Board for really continuous support of our research and extension work, which also includes some of the work on these new technologies. So thank you very much.